5-member cyclic system is going to form where oxygen is one of the ring element. Okay, so one of the constituent of the ring. So 1, 2, 3, 4, 5. Okay, so next to the oxygen there will be a carbon which become O minus. I'm going to abstract the H plus, it become OH. Okay, so on carbon and carbon there is a methyl group. Okay, and as well as the on OH attached to carbon also there is a methyl group. So final product will be this. Okay, it's the same if it is with NH2, that is also going to give the similar kind of nucleophilic addition reaction which is internal. So this lone pair is going to attack, resulting 1, 2, 3, 4, 5. So 5-membered cyclic system is going to generate, and here OH is going to form, and that ethyl is there, and at the NH2 carbon there is nothing. So initially it become NH2 plus, so one H plus is left, so it becomes NH. Okay, so this is the final product. So I asked you to write the mechanism. Okay, so whenever you are writing the mechanism, it's going to become accurate. The final product will become accurate. Otherwise, everything will become the possible products. Okay. So next question. So where there is a competition between the nucleophiles. So there are two kinds of the nucleophiles. Among these, the best nucleophile will be going to attack. Okay. So the best nucleophile means it can donate the electron density in a excess compared to the other. Okay. So where the group which can donate the electron density, that is more nucleophilic, or nucleophilicity of the nucleophile is more. Okay. So among these two, nitrogen and oxygen are the variables. So nitrogen is less electronegative when compared to the oxygen. So when there is a more electronegativity element will be there, it will bind the electron density more promptly, okay, more effectively, so that its donation will be less efficient. So NH2 can donate more when compared to the oxygen. So it's going to give the product. Okay. So resulting into what, 1, 2, 3, 4, 5-member ring. Again, nitrogen will be the constant of the ring, and next to the nitrogen there will be OH, and on to that, so there will be 1, 2, 3, okay, 3 carbons and 1 OH. Okay. So if I make dehydration of this, okay, so there will be further reactivity if any possibility. If I want to dehydrate, okay, so two alcohols can be going to give water elimination and resulting into what, 1, 2, 3, 4, 5-member pyro compound. So this could be the product. If it is dehydration, I have asked for the only this. Okay. So the product will be this. Okay. So there may be a further reaction this time. So make a note on this. Okay. So making of pyro compounds. So this is about the previous class workouts. So today we are going to see one of the important and most repetitive reagent. Okay. So that is what Grignard reaction we are going to see. So Grignard reagent, addition of Grignard reagent. So addition of Grignard reagent always nucleophilic addition. Okay. So it is the one of the best example for the nucleophilic addition reaction. So Grignard means it is RMgX. It is a magnesium based organometallic reagent. Organometallic reagent. So what is organometallic reagent means? It is a reagent which is a organometallic compound. Okay. Organometallic compound, OMC. Okay. So what is organometallic compound means? where there is a metal carbon bond, okay, where there is a metal carbon bond is present, that type of compounds, okay, not uh, carbon means it's not inorganic compound, where there is a organic carbon with metal bond, then organometallic compound. So what are organic metal and what are organic compounds means generally alkyl groups. Okay, this is most repetitive. So organic moiety or organic group. So alkanes are alkyl groups. Okay, with metals you can take magnesium. You can also take lithium. Okay, so you can also take sodium. Okay, these all are metals which are binded to the organic uh, functional groups. Okay, so they are said to be organometallic compounds. Okay, so here we going to discuss about the specific organometallic compound, which is organomagnesium compounds. Okay, organomagnesium compounds. So they are having organic moiety and magnesium moiety along with the halogen. Okay, so Grignard is organomagnesium halides. Okay, organomagnesium halides, which are classified as a organometallic reagents, okay, which are nothing but organometallic compounds. Okay, so we will be going to see different kinds of organometallic reagents, but this is the most repetitive reagent, and why it is repetitive means it has extensive applications in the synthesis of different compounds, because where you can find the synthesis of alcohol, synthesis of acid, synthesis of esters, synthesis of ketones, and synthesis of different amines, so much more. Okay, so you can also synthesize the alkanes also. So there are much more applications with the organometallic compound. So I hope this is going to be most applicative session of our types of reactions. Okay. So here we going to discuss about the organomagnesium halides. So specific example for the organomagnesium halides is methyl magnesium chloride, okay, ethyl magnesium chloride, or ethyl magnesium bromide, okay, phenyl magnesium chloride, phenyl magnesium iodide, phenyl magnesium bromide, okay, so benzyl magnesium halide. These all are belongs to Grignard reagents. Okay, so there are many other Grignard reagents. Okay, but the one common point in the Grignard reagents and organometallic reagents is generally whatever the alkyl group that can act as a nucleophile. Okay, in organometallic reagent, the carbon can act as a nucleophile. Okay, that is the specificity of these reagents. This is the most important point. Carbon will be the nucleophile in these molecules. Why carbon will be the nucleophile means generally if you consider any bond, it will be going to move towards the more electronegative atom. Okay, so when it is a carbon and metal bond, metals are not electronegative, they are electropositive. Okay, they are electropositive means they readily donate the electron density but not accepts. So when compared to metal and carbons, carbon will be the more electronegative atom than metal, and metal will be the electropositive. So resulting the bond towards the carbon, which will make the carbon as a negative. So whatever the alkyl group will be there, that will be more negative. Okay, that will act as a nucleophile. So that is the specialty of organometallic reagents. Okay, so now you understand the nature of the reagent and what is Grignard reagent and what are the types of the Grignard reagent and what are the organometallic compounds, organometallic reagents. Okay, so let's begin the reactivity with the organometallic reagents and Grignard reagents. So if I take any carbonyl compound, okay, so we've been discussing about the addition, nucleophilic addition, especially on the carbonyl compounds. So let's take the same example. So if I take methyl magnesium bromide, So this is a Grignard reagent. Okay. So what could be the nucleophile here? Here nucleophile will be meter and this will be positive. Okay. So magnesium will be in plus 2 and Br will be minus 1. So minus 1 and minus 1. So minus 2. This will be equal to plus 2 which is neutral. Okay. So if at all it is breaking, it will become CH3 minus and MgBr plus. Okay. So CH3 minus and MgBr plus. Okay. So this could be the breakage of the molecule. Okay. So whatever the nucleophile that is generated will be going to attack on the carbonyl. So it becomes CO minus and R and this is methyl. Okay. So further if I treated with H3O plus, where H plus and H2O will be there, it will acquire the H plus, so resulting into the alcohol. Okay. Which type of alcohol? It is a tertiary alcohol. If I treat a ketone with a Grignard reagent, it's going to become tertiary alcohol. Okay. If I treat a aldehyde with Grignard reagent, so let's see what could be the product. So this is minus and will become plus. So it's going to attack resulting RCO minus and CH3 H, where H3O plus will give proton. If I didn't write this water, you should not undergo the proton addition. It will stay here only. Okay. So if I give any electrophile, that will be going to attack on the O minus. Okay. So be careful with that. So it is R O H H C H. So what kind of alcohol? It is secondary alcohol. When you treat aldehyde with Grignard, it's going to give secondary alcohol. When you treat ketone with Grignard, it will give tertiary alcohol. Okay. So remember, I have already suggested or mentioned the applications of the Grignard reagents. It will be useful in different kinds of alcohol and different kinds of synthesis of other products like carbonyls, okay, esters, acids. So this is the application towards the synthesis of alcohols, okay, where you are using nucleophilic addition reactions. Okay. So let's try some examples based on the alcohol formation. Later we'll see the products of the other alcohol formation and other ketones and ester formation. Okay. So what could be the product when I treat with cyclohexanone with methyl magnesium bromide followed by the water. So this is first, this is second. So X is option A, 2-methyl cyclohexanone, option B, 2-methyl cyclohexanone, option C, 1-methyl cyclohexanone, option D, 1-methyl cyclohexanone. So what could be the product? Come on, Surrender, Sidhu, and who are the on that? They can give the answer. Yeah, it is going to attack here. Yeah, this become this. 1-meter cyclohexanol. Okay. Okay. So next, Chandru, please mute the mute your sound. Yeah. Am I audible? So yeah. Next question. Uh, Grignard readily reacts with option A formaldehyde, option B acetaldehyde, option C benzaldehyde, option D acetophenol. So this is one of the important reactions. So similar to the yesterday what we discussed, nucleophilic addition reaction. So this is also similar type. Yeah, because where there is a less electron density or where there is a carbon with more electrophilic nature, there will be the attack. Okay, so it has less psi groups or no psi groups, so this can be donatable. Okay, so here because of the conjugation it will be increased, because of the conjugation and psi groups it will be increased. So comparatively, formaldehyde is the one which is most reactive towards the nucleophilic addition reaction. Okay. So in the earlier reaction, we have seen the secondary alcohols synthesis with RMGX of the aldehyde, okay, and tertiary alcohol synthesis with ketone, okay. So if you want the primary alcohol, you need to treat with the formaldehyde with the grignard, okay, resulting into only primary alcohol, okay. So remember that. So for the making of primary alcohol, you need to treat with formaldehyde. Secondary, any aldehydes. Tertiary, ketones. Okay. So there are some exceptions for the Grignard. For example, if you consider a starting material like this, which is bulky and more substituted. Okay. So if this is the case, if I treat with ethyl magnesium bromide, okay, so there won't be any reaction. Okay, remember this. Where there is a sterically hindered starting materials are there, they are repulsed. They are not able to attack on the carbonyls because they are less efficient in presence of the steric hinder. So such type of systems will not give nucleophilic addition reaction. So this is the exception. Okay, so make a note of this molecule. So next, one of the previous question, conversion of cyclopentanol to the methyl cyclohexanol. Option A methyl magnesium bromide followed by the H2O. Option B CH2N2 followed by methyl magnesium bromide H2O plus. H3NGBr, then CH2N2, then H2O. This is nothing. So if this is the case, so here you can now identify that this is happened when a cyclopentanone system, cyclohexanone system attacked by the methyl magnesium bromide. Okay, this you can identify. Okay, so for the conversion of cyclopentanone to the cyclohexanone is the question now. Okay, ఇది ఆల్రెడీ డిస్కస్ చేసినాం. ఓకే, మిథైల్ అటాక్ అయితే సైక్లోపెంటనోన్కి మిథైల్ అటాక్ అయితే ఈ ప్రొడక్ట్ ఫామ్ అవుతుంది. ఓకే, సో మరి దీని నుంచి దీనికి రావాలి అంటే అప్పుడు రియేజెంట్ ఏంటంటే డయాజోమీథేన్. ఓకే, సో డైఅజోమీథేన్. సో దిస్ ఇస్ a kind of nucleophilic addition reaction only, where CH2 minus and N2 plus will be there. Okay, so I'm writing shortened form. So this will be going to attack. So, okay. So here it will be going to ring expand. Okay, with the elimination of N2. CH2 added up here. Okay, and O minus will be here. Okay, so this will be positive charge here. Okay, so plus and minus together will be going to form carbon. Okay, if you see deep mechanism, there will be carbene formation. Okay, that I am not discussing. Just I am giving overall the reaction pathway. Okay, so there will be carbene formation, and that will be rearranged to cyclohexyl system. Okay, so whatever may be, so overall it's going to give one carbon addition. Homologation of the carbonyl can be possible with the diazomethane. Okay, homologation means addition of CH2 or one carbon extra. Okay, so you can convert cyclopentane to pentanone to the cyclohexanone, where after cyclohexanone formation, if I treat with methyl magnesium bromide. Okay, so this is going to be this resulting what after of methyl. Okay, so which on H3O plus is going to become this. Okay, so in organic chemistry there will be the questions which are interdisciplinary, means two or three reagent systems are nomenclature based or stereochemistry based will be the questions. Okay, name of reaction based. So all together mixed up and they will be given as a example if it is a difficult question. Otherwise there will be one or two concepts like this. So it is the application of diazomethane reagent and application of Grignard reagent, where you been studying nucleophilic addition reaction. Okay, so write down this reagent also, diazomethane, which is used for the homologation of ketones. Okay, homologation of ketones, which is a nucleophilic addition reaction. Okay, so this is asked in IIT JAM as well as the HCU papers. Okay, so it is one of the previous questions which is very important. So please focus. Okay, any doubts? Let's see one more question. So here it is given two carbonyls, and which is more reactive towards the nucleophilic addition reaction. So in these two, they are look like similar, but the thing is here CC single bond rotation will make this methyl group up and methyl group down. Okay, there is a possibility of rotation of the methyl group, which will cover the more area around the carbon. So steric repulsions will be in this area, where Grignard reagent addition will be different, okay, will be discussed. So if the size of the Grignard reaction is more, the steric crowding will be more and the reactivity will be even difficult in terms of steric crowding. But in terms of nucleophilicity, it will be more efficient because as the flexi groups increases, they will be more nucleophilic. Okay. So you need to see the both steric factor as well as the nucleophilicity. So nucleophilicity is more, but the thing is steric factor will be more. So if there is a steric crowding, it will not happen. Okay. So whereas in cyclic systems there will not be CC rotation. So one direction is occupied with the alkane system, but the other side is very available for the Grignard. So in terms of reactivity towards the methyl magnesium bromide, so this is more reactive. 3-pentanone, 3-cyclopentanone is more reactive when compared to 3-pentanone. Okay. So this is also asked in BHU, I think. So let's see the reagents of lithium reagents. Okay, there are some more Grignard reactions, but this is a kind of similar to the Grignard. So let's see this also. So organo lithium reagents attacking on carbonates. Okay, attacking on carbonates. So if I take ketone and treated with methyl lithium, okay. So among these, carbon will be more electronegative when compared to lithium because lithium will be positive. Okay, carbon will be negative. So this is going to act as a nucleophile. It will be going to attack on the carbonate, resulting into C, O minus, and R, and methyl group here. Okay. So when this is found, lithium will be stabilized. Okay. In the earlier also, the O minus can be stabilized with magnesium bromide. That is also possibility. Okay. So here lithium can stabilize. So this is called organolithiates. Okay. So when it is treated with acid or water, so it's going to give alcohol. Very similar to the Grignard reagent. Okay. So that's why here you can correlate or compare. So when it is ketone is treated, it is tertiary alcohol. Okay. Where there is a aldehyde is treated, it's going to give secondary alcohol. Okay. O minus and Li plus R H. So, so this is secondary. If I need primary, I need to treat with formaldehyde. Okay. If I need primary, I need to give formaldehyde. No H. So it is primary alcohol. Okay. So similar to the Grignard reagent. Okay. So try to work out some examples. First one, propanaldehyde treated with ethyl magnesium bromide. That could be the product. Again, butyraldehyde treated with methyl magnesium bromide. That could be the problem. So if I write H2O, then you must use alcohol. Otherwise, you must use anion only. Okay. So in third, which will be going to react? Either aldehyde or ketone. So the aldehyde, which has more reactivity towards the nucleophilic addition reaction. So aldehyde must be reactive. Next. mm, So what are the starting materials to make this? Okay. So these are the four questions that you need to work out. Take the screenshot, and we'll be going to see other nucleophilic addition reactions. Next, Grignard with esters. Okay, acid derivatives. R C double bond O CH. Okay, so this is there, ester is there, and I am treating with Grignard. Let's say methyl magnesium bromide I am treating. Okay, so here nucleophilic generation will be from the Grignard, and nucleophilic addition will be at the carbon and carbon. So it's going to happen. Where this can act as a leaving group. Okay, L will indicate as a L, leaving group, resulting into what? So ester has become ketone. Okay, by the treatment with the Grignard. Okay, if I again treat with the same Grignard reagent, so what could be the product? So again it's going to attack and it becomes RO minus CH3 CH3. This will be stabilized with the MgBr. Okay. So this needs water workup so that it will pinch the anion resulting OH, CH3, CH3. So with 1 mole of Grignard, okay, it given ketone. With 2 moles of Grignard, it given tertiary alcohol. Okay, tertiary alcohol. So if I write the reaction like this, C double bond O O CH3. Okay, so 1 mole of methyl magnesium bromide. So you need to write C double bond O CH3. So write 2 moles of methyl magnesium bromide. So you need to give alcohol. Okay. So this is the product formation in different stages. Okay. Let's solve a question. Ethyl acetate is treated with 2 moles of ethyl magnesium bromide. What is the IUPAC name of product? So what could be the product name? Here I am taking ethyl ester and treated with 1 mole of ethyl magnesium bromide first. So it is going to become ketone. So ethyl will be added. Again another mole of grignard. So this become alcohol. This is tertiary alcohol. Okay. So if I add water. So it is what 3-methyl pentatriol. Pentatriol. So this is what the IUPAC name of the product. 3-methyl pentatriol. Okay. So based on grignard, you can make many questions and you can expect many questions in different examinations. So try to apply the reagent in different systems. Okay. So you can find different types of the reaction. Okay. So let's make a treatment of the amide with grignard. What could be the product? And acid halide with grignard. What could be the product? And anhydride. What could be the product? So the thing is that dissolve on one molecule, they will give ketone. Okay. So if it is second mole, they will give alcohols. Okay. Dissolve are going to give such kind of systems where with one molecule of grignard reagent, it will be ketone. With the two molecules of the grignard, it will be alcohol. Okay. Try to write all the products. Okay. And see if any difference between them or similarity is between them. You need to observe. Okay. So apart from the grignard, there are many other nucleophiles, but the thing is there is a important point about the grignard. Grignard so far you have seen as a nucleophile. Okay, methyl as a nucleophile. Okay, so but the thing is when it is uh, in presence of acidic groups or proton, okay, acidic proton if it is available, acidic protons means if it is acid, this H plus can be released. If it is alcohol, this H plus can be released. Okay, if such kind of systems are there, okay, when acidic protons are available, not only grignard can act as a nucleophile, it can act as a base. Okay, it can act as a base. So what is it? It will obstruct the proton. Okay. If such systems are there, if I treated with acidic proton having compounds, then this acts as a base, it will obstruct the proton. So CH3 with proton, it becomes CH4 and this becomes magnesium ester. Okay. So wherever the acidic proton is there, it will give alkane. So I also mentioned that grignards are used for the synthesis of alkanes. So for the alkane synthesis, you must react the Grignard reagent with the acidic proton. So acids, alcohols, if it is treated with Grignard, they will be attracting the proton of such systems, so resulting into the formation of alkane, which is of Grignard reagent. ఓకే సో గ్రిగ్నాల్ రియేజెంట్లో ఏదైతే ఆల్కైల్ గ్రూప్ ఉంటుందో దానికి సంబంధించిన ఆల్కైల్ని ఫామ్ చేస్తాయి. సో యాసిడిక్ గ్రూప్స్ ఏవేవి ఉంటాయి అంటే acids, alcohols, and you can take the amines. So amines can also be treated and they will form NH and GH. So it is a bit of stronger base like, so it will attract the proton. So it is treated with meter magnesium boron. So it will be meter. Okay. Or if I treat with like estolins. Okay. So CH, this is also acidic proton. So if I treat with the grignard, that will also going to give acetylide, okay, magnesium acetylide as well as alpha. Okay. So be careful when you are treating with grignard reagents. So there are not only nucleophilic addition reaction, there are side reaction which will be proton abstraction reaction. Okay, proton abstraction reaction where acidic proton is present. If it is not acidic proton, they will be going to give nucleophilic addition reaction. If it is acidic proton, there will be a proton abstraction reaction or acid base reaction. Okay, so this is about the Grignard reagent. So if any doubts, you can ask. Okay, so after this Grignard, we will be going to see the okay. So after this, we are going to see the different kinds of the nucleophiles that are going to attack on the carbonyl system. Okay. So if I take any carbonyl, any nitrogen based reagents. Okay. Let's say I am taking amine. Okay. So this can act as a nucleophile will be going to attack. Okay. So not only that, if you take secondary amine also, then it is going to give just a second. Sorry for the inconvenience. So you can take the secondary amines which can also act as a nucleophile. Okay. You can take the hydrazine. Okay. So among that, one of the nitrogen can act as a nucleophile. Okay. You can also take the phenyl hydrazine. So there is a DNP test which is used for the carbonyl identification in which 2,4 dinitro phenyl hydrazine is used. So this is what 2,4 dinitro phenyl hydrazine. So that can also among these two nitrogens. So this is attached with the conjugation. Okay, this is non-conjugated, so this will be more nucleophilic, so it is going to affect. Okay, even you can use the hydroxyl amine, so which will give the answer. Okay, so these are the nitrogen based nucleophiles which will give nucleophilic addition reaction. Okay, let's try to write the product. So this is going to attack. So what happens? O minus and NH2 plus and R. Okay, so among H2 and H plus will be going to move, and that will be abstracted by this, resulting OH H. Okay, so H and OH are side by side. They can release the H2O, resulting into what? Double bonded. So whatever the groups are there among hydrogen, nitrogen, whatever the hydrogens are there, they left as H2O and the oxygen are left as a H2O. Okay. So resulting into what? These are the double bonds that will be retained on the nitrogen. So this is what the same system. Okay. So this is called imide. Okay, imide. So amine on reaction with the ketone will result imide. Okay. So if it is primary amine, it will give imide. Okay. So if this is the case, so it will also go and attack. So let's make this. So resulting into what? O minus and H plus. So H plus will be leave and this will be abstracted. So further H2O release will not happen because there is no hydrogen on the nitrogen. Okay, so it will stop over here. Tertiary amine will be going to form. Okay, so if it is hydrogen, will be going to attack. Name is hydrogen. This is hydrogen. So O minus and NH, H, NH2. Okay, so H plus left and this will be abstracted, resulting into what? N, OH, NH. Okay, so H2 will be left, resulting into NH. Okay, so this is called hydrazine. Okay, before the product formation it is hydrazine. After the product formation it is hydrazone. Okay, so this is acetone. So acetone hydrogen. Okay, acetone hydrogen. So this is phenyl hydrogen. So what you understand? This H2O will be left and it is going to form double bond. So similarly, H2O will be left and it is going to form double bond. You can write the product directly. So this is phenyl hydrogen. This is phenyl hydrazone. Okay, phenyl hydrazone. So which is made up of acetone. So acetone, phenyl hydrazone. Not only aldehyde, not only ketone, you can take the aldehydes also. Any carbonyl compound, will be going to give nucleophilic addition reaction. So based on the reagent type. So this is 2,4-DNP means 2,4 dinitrophenyl hydrazine. After the product formation, if I take the acetone, it is going to give 2,4 dinitrophenyl hydrazone. Okay, try to write the names also when you are writing in your notes. Okay, so this is NO2 dinitrophenyl hydrazine. Wherever the carbonyl compound is there, the 2,4-DNP reagent will react with the carbonyl compound and form orange yellow color precipitate. Okay, so PPT will be formed. So based on the PPT formation, we will be going to confirm that there is a carbonyl group. Okay, carbonyl means it may be aldehyde, it may be ketone. Okay, so these all reactions will be given both the carbonyls. Okay, aldehydes and ketones. Okay, so this is hydroxylamine. If system is hydroxylamine, again it is going to form the double bond. So NOH. This is called oxide. Okay, so oxide formation. So these are the nucleophilic addition reaction based on the carbonyl and the nitrogen. Okay, so you might have studied in carbonyl compounds. Okay, but I am repeat, I have repeated. Okay, so thing is that whatever the perfection that you are going to attain is a matter. Okay, so whatever may be the nucleophilic addition reaction. So here I am covering almost all nucleophilic addition reaction. Okay, so thing is that you need to take the different compounds and different reagents and try to write the products. Okay, as much products as you can try to write. Okay, take the acetone example, take the benzaldehyde, take the benzophenone, take the estophenone. Okay, take the cyclopentanone, cyclohexanone, and write the different products with these all kinds. Okay, so for the workout, so the same reagent, so you can take the cyclopentanone and write in the your note and try to produce the photo in the group. Okay, cyclopentanone and benzophenone. Okay, and formaldehyde, acetaldehyde. So try to write the product and give the name also. Okay, here I explain how to give the name. Okay, so try to give the name also. Okay, and submit in the group. Okay, so this is about the nucleophilic addition reaction based on different nitrogen substituents. Okay, so tomorrow we're going to see other reagents for the nucleophilic addition reaction as well as the Michael addition. Okay, Michael addition reactions. Okay, so after that we'll be going to see the free radical reaction. So if any doubts you can ask.